Today our focus is on D block element. Now what is it? To understand this D block element, at first we have to know about different blocks of periodic table. What are they? One is S block element, another P block element, another D block element and F block element. There are altogether 4 blocks of element in periodic table. A periodic table is not only divided into group and period, it is also divided into 4 distinct blocks. Now I want to locate their position in the periodic table. Look at this is modern periodic table in which S block element is at the left hand side, group 1A and 2A. The vertical column which forms group 1A and 2A are S block element. It is at the left hand side of the periodic table, and at the right hand side look at this 3A, 4A, 5A, 6A, 7A and 0 group element. They are P block element. Now the D block element is in the middle part. Look at this central part of this modern periodic table represents D block element, and at the bottom there are 2 rows of element that represents lanthanides and actinides. Thus a modern periodic table is divided into 4 different blocks of element. One is S block, another is P block, another D block and another F block. Today's focus is on D block element. That's why I want to talk about D block element. What is D block element? It can be defined this way: elements in which the last electron enters any one of the 5 d subcell of their penultimate cell are called D block elements. Elements of groups 3B, 4B, 5B, 6B, 7B and 1B and 2B are D block element. First I want to see the position of this D block element. Look at this. This is D block position of D block element. It is in the central part of the periodic table. Here it starts from this point: 3B, 4B, 5B, 6B, 7B and 8 group, and then 1B and 2B. All these are D block elements. Now we want to go through this definition again. What is called last electron enters into any one of 5d subcell? What it mean? The meaning of this saying is an atom might have 7 different cells. They are K, L, M, N, O, P, Q, or first, second, third, fourth, fifth, sixth, seventh. And out of these 7, beside first and second, from third cell to 7th cell, they might have D subcell, although they do not have. And that's why the electron, last electron, if fills into one of these 5d subcell, then that is called D block element. It cannot be understood so easily with this sentence. I want to go through atomic structure. This is the normal atomic structure of atom, and I want to show you this first. An atom has got one nucleus. It is central part which is surrounded by one or more than one cells, and nucleus is the central part and cells is the outer part of an atom, and this cells contains electron which revolves around the nucleus, and the cells are named as K, L, M, N, O, P, Q. This way from first, second, third, fourth, fifth, sixth, seventh also we can see. This is the normal atomic structure of atoms. But these cells are further divided into subcells. 4 different subcells. Look at them. What are they? S. This S subcell can hold 2 electrons. In the same way, there is another subcell. P subcell can hold 6 electrons and D subcell can hold 10 electrons. F subcell can hold 14 electrons. Each of these cells might have subcells, but some of them have only one subcell, some of them have 2 subcells, some of them might have 3 and 4 also. Let's talk about the filling up of electron in different subcells of each of the cell. It can be filled, or it can be understood by this rule which is called Aufbau principle. According to this Aufbau principle, at first we have to fill up the electron in first cell S subcell, and then we have to go to second cell S subcell, and then we have to go to second cell P subcell, and then third cell S subcell, and third cell P subcell, and after that fourth cell S subcell, and then 3 third cell D subcell, and fourth cell P subcell. This way we have to fill up the electron. This is the method of filling up of electron in different subcells of different cells. Now I want to take one example of D block element. This is iron. Its atomic number is 26. What it means? It means it has 26 electrons in its different orbits. Now we are going to fill these electrons in different subcells. First we will fill this first cell S subcell with 2 electrons, because S can hold only 2 electrons, and then we have to go to second cell S subcell. Here it is given in above principle. It can hold two electrons, and then we have to go to second cell P subcell, and this second cell P subcell can hold 6 electrons according to our information. That's why 2p6 I am writing. And then we have to go to third cell S subcell, which can hold only 2 electrons, and then we have to go to third cell P subcell, and this can hold 6 electrons. That's why 3p6. Now we have to go to fourth cell S subcell, and S subcell can hold only 2. How many electrons are filled? Now let's take it. 2 plus 2 4 plus 6 10 plus 2 12 plus 6 18, and including this 2, altogether we have 20. Now how many electrons are left? 6 electrons are left. And now where we are, 4s, here we are. Now we have to go to 3d. Now D subcell can hold how many electrons? Here it is written 10 electrons, but remaining electron is only 6. That's why the 6th electron enters into D subcell of this third cell. Now what happened? Last electron entered into D subcell of the penultimate cell. Penultimate means what? Second last cell. Second last cell is called penultimate cell. Here how many cells iron contains? Altogether we have 4 cells. Total 4 cells. And which one is penultimate cell? Second last cell, that is third cell. And that's why the last electron entered into D subcell of the penultimate cell of this atom of iron. That's why iron is D block element. In the same way, in case of every D block element, the last electron enters into D subcell of the penultimate cell of their atom. Okay, this much for today.